Okay, hold on one second. Let's go to number 13. So let's just look at what this is talking about here. Some of the vocabulary that's new here is where it says varies directly. And I want you to think about when we talked about proportional and non-proportional. So when it was proportional, it was just multiplication only, remember? It might be mx or kx. This just meant multiplication only. It was proportional relationship, right? And then if it was non-proportional, it had something added or subtracted to it along with multiplying by something, right? And so when we talk about something varying directly with something else, that means it's just going to be multiplication as well. So it's just this proportional relationship going on where multiplication only is happening, or division if you do it the reverse way, right? To solve for one of the missing parts. So it says the amount of water a washing machine uses to wash clothes varies directly with the number of loads of clothes. The washing machine uses 36 gallons of water to wash 3 loads of clothes. So I'm going to start thinking about this. So it takes, for every 3 loads, it takes 36 gallons, right, of water. So water in gallons and then clothes, right? The number of clothes loads. And so if we wanted to set this up, I could just be like, put it in a table or just think about the relationship. So I'm just going to go ahead and put this in an XY table. So for every 3 loads, it takes this many gallons of water. Okay? 36. So that's just our relationship, what's going on. Then it says, how many gallons of water will the washing machine use to wash 8 loads of clothes? So we want to know this here, right? Well, if you can figure out what's going on here, it's not going to be too bad. And here's a big clue on this. It said it varies directly. If it says that, you know it's a proportional relationship. You know it's multiplication only. So you can go over here and say, what times 3 equals 36? And if you don't know that, can't we just divide 36 divided by 3 to see what it would be? Or we can guess and check, right? And so let me just say I'm trying 12 times 3. Oh, look, I was right away. But that's because I remember my facts. But you could have just checked that way. And so if this is the relationship once and it told you it varies directly, what's going on here, then you know it's proportional. You can just go ahead and apply that times 12 to the 8 as well. And then I know you have a calculator to do this. I'm just not getting up to get one. The answer here would be 96. So all this is really finding what rule happened and applying it to whatever they ask for now. And if it varies directly, then it's letting you know it's going to be just multiplying like that. Okay. All right. Number 14. Mrs. Fuentes buys her lunch in the school cafeteria. The cost of 15 school lunches is $33.75. So just to think about my XY thing going on, the number of school lunches is my X and the cost is the Y value, right? That's what it shows on the graph. Which graph has a slope that best represents the average cost of lunches in dollars per lunch? Well, the first thing I'm going to do is notice that they don't have 15 school lunches on here, do they? They really don't. So I'm going to see, I see that it says per lunch. So think about that. I need to see what one lunch is worth, right? So same thing, kind of as earlier. If I know that my X's are the number of school lunches and my Y's are the costs, I can plug it in here and think about it. So for 15 school lunches, it's $33.75. Well, it says average cost, and so I know it's going to be similar, and it wants to know per lunch or the same because we're going to get the average here. But how would I get it for one? So remember earlier we said, well, if it says direct variation, you can just multiply. Well, on this one, it's going to have to be multiplied too because they're taking it down to per lunch for just one lunch, right? And average cost is a sign that we're going to be splitting it up evenly. And so when you go to figure this out, it's not so easy to say, 15 times what equals 33.75, but you can go do 33.75 divided by 15 to see what you multiply by. And so that's what I'm going to do here. I'm going to say, well, it was 33.75 for 15 lunches, so how much is it for one lunch? And look, it's 225 for one lunch. They just said that. And to make sure that rule works, go ahead and do $2.25 times 15. Times 15. And you get the 33.75. So you know one lunch is 225. Once you figure that out, you can come over here and look for over 1 up 225. And that looks like over 1 up 225, possibly. That looks like over 1 up 6 something. That looks like it's not going to even be above $2. If we followed this trend line, the 1 would be somewhere right here. If we drew the line, the 1 would have been somewhere like right here. That's not even close to $2. And then this one has same thing. Let's look at that line. That's not even going to touch up there to $2 either. This is the only one that shows at $2.25 per lunch. And so if you wanted to check one more, let's see what 2 would be. It'd be 225 times 2, right? So 450. And just see if that's on there too. So over 2 up 450-ish. Yeah, that's about right because halfway would be 5. That's pretty good too. So I'm satisfied that this is the best graph. So sometimes they're going to give you like a situation and you have to think about what's going on there, find the rule or the price for one thing, and then go use those to match up your graph because otherwise they don't have the 33.75 and the 15 on there, but you can find the relationship, right? For that one.